So in this video, we're going to do a fundamental introduction to logarithms. And when we say fundamental, we're only talking about the basic understanding of what a logarithm is. And so we're going to talk about how to convert from exponential form into logarithmic form and vice versa, and as well as solving simple logarithmic equations. But first, let's talk about what that relationship between exponential form and logarithmic form is. So, for starters, the logarithmic form is stated as log base b of x is equal to y. However, in the exponential form, b to the y is equal to x. So it turns out that the logarithmic form and the exponential form have some sort of relationship. In fact, they have an inverse relationship, which we will talk about in another video. But for starters, there are some constraints we need to know in order to understand what a logarithm is and how it's related to the exponential form. First, b has to be greater than 0 and not equal to 1, and x has to be greater than 0. Long story short, the reason that b cannot be equal to 1 is if you go into exponential form, if you take 1 to any power, the end result will be 1. So in fact, you'd be looking at a horizontal line of y equals 1 for the equation. However, we want b to be something greater than 0, not equal to 1, so we can see that the graph would be exponential or not. And x cannot be greater than 0. X has to be greater than 0 because there's no such thing as a log of a negative number. In fact, if you plug in the log of a negative number on a calculator, it would be considered undefined. In this first example, we have 5 to the third equals 125, and they want us to convert it into logarithmic form. So first, let's restate that the exponential form b to the y equals x can be transformed into log base b of x equals y. Now, what I would do first with this problem is identify what b, y, and x are in the exponential form, and so we get that b is equal to 5, y is equal to x is equal to 125, and y is equal to 3. And if you put that all into logarithmic form, you get the log base 5 of 125 is equal to 3. So remember, it's just a pattern game. You just eyeball it using 5 to the third equals 125 and b to the y equals x. You can just see that everything lines up. In example 2, however, we want to go from logarithmic form into exponential form. So as a reminder, log base b of x equals y is the same as saying b to the y equals x in exponential form. So first, identifying b, x, and y are important. So b is equal to 1/2, x is equal to 16, and y is equal to -4. And if we put 3 and 3 together, we get 1/2 all raised to the -4th power equals 16. Now, in example 3, we're solving a simple logarithmic equation, such as log base 2 of x is equal to 5. But in order to solve a logarithmic equation, you need to first put it in exponential form. So remember that log base b of x equals y is the same as saying b to the y equals x in exponential form. So, just jumping right there, log base 2 of x equals 5. By just lining things up, we get the following. We get 2 to the 5th equals x, and if you use a calculator, 2 to the 5th gives you 32, so x is equal to 32. Example 4, slightly different but still doable. Log base 3 of 1 over 27 equals x. So first, jumping right into it, exponential form, 3 to the x equals 1 over 27. However, if we want to solve this exponential equation, we need to realize that we need bases of 3. And 27 can give us that base of 3 because 3 to the x equals 1 over 3 to the third power. And if we look back at properties of exponents, we know that 1 over a to the m is equal to a to the -m, which would then give us 3 to the x equals 3 to the -3rd. And voila, we get x equals -3. So there are some logarithmic equations where you need to use properties of exponents to simplify, especially if you need to get a negative exponent in order to solve them. So just keep that in mind that you're doing different types of examples. And in the last one, we have log base 3 of -1 is equal to y. This time we're solving for the y variable. And that first, putting in exponential form, 3 to the y equals negative 1. However, if you think about it, there's no value of y that if it's 3 to that power would give you negative 1, so automatically this is no solution. And similarly, if you look at the x value here, it's negative 1. However, the constraint in the past was that x has to be greater than 0. So therefore, that is another quick case of no solution. Now, hopefully this video helps you understand what a logarithm is and how to solve simple logarithmic equations and converting from logarithmic form to exponential form.